Assalamualaikum warahmatullahi wabarakatuh. The poster is basically about my work on identification of all-palm acetyl-CoA carboxylase, also known as ACCase, and the classification of the genes family into multifunctional and multi-subunit forms using domain analysis. ACCase is considered one of the most important enzymes in the regulation of fatty acid biosynthesis pathway, which shown in figure 1, where it catalyzes the first step of fatty acid biosynthesis pathway, indicated in red box in the figure 1, where it shows the conversion of acetyl-CoA to malonyl-CoA by ACCase. Malonyl-CoA is important because it is required for both fatty acid initiation as well as fatty acid elongation. The genes family supposedly contains 4 domains, in short form known as CT-alpha, CT-beta, BCCP, and BC. They could present as a single protein known as multifunctional form, having all 4 domains, or as 4 separate proteins known as multi-subunit form. The multifunctional ACCase is found in cytoplasm, while the other is in the plastid. In all-palm, both forms are present, and the one that is involved in all-palm fatty acid production is the multi-subunit ACCase. The methodology begins by downloading the ACCase gene sequence of Arabidopsis from CAC website, and that sequence is used as reference and as query to identify all-palm ACCase gene sequence. And later we perform domain search using InterProScan to identify which domains could exist in the ACCase gene sequences. We identify 7 domains exist in Arabidopsis ACCase gene sequence, where we use that information to help us classify all-palm ACCase gene sequence into multifunctional and multi-subunit forms. As a result, we identify both forms of ACCase, where 3 copies of CT, 2 copies of BCCP, 2 copies of BC were identified as multi-subunit form, and 2 copies of multifunctional form having all 4 domains were identified. This work is agreed with previous work by Wan Omar 2008, who reported the existence of 2 distinct forms of ACCase in all-palm.